So remember, you can use notes, and for this slide right here, your notes come from the very first lesson, 3.1, and they're all on that kind of yellow colored paper. So let's see if we can use the diagram to complete the statement with either corresponding, alternate interior, alternate exterior, or consecutive interior. Number 5, 3 and 6. This guy and this guy, they're on the inside, they're in the middle, so they're going to be consecutive interior. Number 6, 4 and 6 are on the inside, they are also going to be interior. Oh shoot, I messed up. This should actually be, these are consecutive interior because they're on the exact same side. The one before, where it was 3 and 6, they're interior, but one is on the left side and one is on the right side, so those are alternate. Gosh dang, not alternate exterior. This is the guy we want. Alternate interior. So interior's in the middle, alternate, one on the left side, one on the right side. Let's try number 7. 2 and 7. Okay, one is on the left and one is on the right, so they're going to be alternate, but one's on the top, one's on the bottom, so they're on the outside. So these guys are alternate exterior. Number 8. 1 and 5. Okay, 1 and 5, these are probably the most important ones, maybe. Oh. Okay, 1 and 5. They're kind of in the same location. 1 is in the top left of this group of 4, and 5 is in the top left of this group of 4. So if they're in the same position, they are called corresponding. Number 9. 1 and 8 are kind of like 2 and 7. So same as number 7. These are alternate exterior angles. Okay, now the bottom part. Assuming that those lines are parallel, revisit questions 5 through 9 and determine if each pair of angles are supplementary or congruent. So when your lines are parallel, these 8 angles, half of them are going to be congruent, the other half are going to be congruent, but the ones like 1 and 2 will always add up to be 180. So half are going to be congruent, the other half will be congruent, but they will be supplementary to each other. So they're going to add and give you 180. So number 5, 3 and 6. And on the test, I would do this on a piece of scratch paper. Draw your own. So this is a nice trick to have. Draw your own set of lines and make up your own angles. So I'm going to say that's 100 degrees. That's 100, that's 80. That's 100, that's 80. And then these top 4 are going to be the exact same as the bottom. So that's 100, that's 80, that's 100, that's 80. Okay, now if you're looking at this, it's going to be a lot easier to tell. So angle 3 and 6 is kind of this and this. 100 and 100, they are congruent. So 5 would be congruent. Okay, 6, let's look at 6. 6 is angle 4 and 6. So 4 and 6, let's find them. 4 and 6 would be here and here. So if I look on my picture, 4 and 6 are here and here. And those are supplementary. So number 6 would be supplementary. Okay, let's look at 7. Angle 2 and angle 7. So find it, and then find it in your own picture. 2 and 7. It looks like they are congruent. Okay, angle 1 and 5. So find it here. 1 and 5. Then look at your own picture. They are also congruent. And the last one, number 9. 1 and 8. 1 is there, 8 is there. So find it in your picture, there and there. Those are congruent. Okay, is it possible to prove that the lines are parallel? So it's kind of a yes, no. If yes, what is your justification? Okay, number one, you're going to have to do a little bit of fill in the blank. I know that this guy right here, those two are on a straight line, so they add and do 180. So if I take 180 and minus 124, I do get 56. So I know that this angle right here is 56 degrees. Okay, now check this out. This angle and this angle are in this. They're both in the top right, so they're in the same location. They're corresponding angles. So your answer is yes, they are parallel, because parallel lines have congruent. So congruent corresponding angles. Congruent corresponding angles. Corresponding angles are only congruent if your lines are parallel. So I do know those lines are parallel. Okay, number two. This angle 132 is corresponding to this big angle right here. So if I add up these two slivers and they do equal 132, if I take 58, add 74, I do get 132. So these two added together are 132, and this is going to be the exact same reason as number two. Corresponding angles are congruent only if your lines are parallel. So these lines must be parallel. So the answer is yes, and the exact same reason as number one. Okay, number three looks probably like it's going to be the toughest. 3, so if you look at these, so if you remember this, 180, 180, 180, 100. If you look at your own picture, here's what they want you to look at. They want you to look at these two angles right here. So the consecutive interior angles, and what you know, if your lines are parallel, consecutive interior angles always add up and give you 180. They're supplementary. So this angle right here is 79. So 79 add, if I add these two together, then those will be your consecutive interior. And if they add and equal 180, my answer is yes. So I'm going to take 79, add it to 48, add it to 53, and if my answer is 180, I'm in business. 79 plus 48 plus 53. Okay, my answer is 180 degrees. So your answer is yes, they have to be parallel. Your reasoning is because consecutive interior angles are supplementary. And your consecutive interior angles are only supplementary if your lines are parallel. Okay, same kind of idea. So you're given the information. Can you prove that these lines are parallel? Number one, we just barely did. These are consecutive interior, and 50 plus 130 is 180. 180 is your mark. If they add and give you 180, your answer is yes. Number two is the obvious yes, because that's the top left, that's the top left, those are corresponding. Corresponding angles are only congruent if your lines are parallel. So 2 would be yes, and then you write that out. Corresponding angles are only congruent if your lines are parallel. 3, you got to add something to it. There's really not enough info as it is, but I know that this whole line right here is 180 degrees. So if 75 of it's being used on the left side, how much is left over for the right? 180 subtract 75 So I'm going to do 180 minus 75, and I'm going to get 105. So this angle right here is 105 degrees. This angle is corresponding with this. And one of them's 105, one of them's 115. So my answer is no. Because corresponding angles have to be the exact same if your lines are parallel. So those lines must not be parallel. Okay, 4 is a good question. 4 is yes. Because alternate exterior angles are congruent in parallel lines. So x is whatever. If I say x is 40, then this angle right here would be 40, and this angle would also be 40. Then the rest of it would be 140. 40, 140. So whenever your alternate exterior angles are the exact same size, then you must have parallel lines. Okay, number 5. These are congruence marks. So these marks mean whatever the angle is. So if I choose it, and choose whatever you want, I'm just making up a number. If I say that's 70 degrees, then this one will be 70 degrees. That must mean this is 110 and this is 110. So I've got 4 of them, but there is no way to jump to these left 4, because I have no idea how they're related to the right 4. So no, not enough info to determine that P is parallel to Q. All I can fill out is those 4 angles. There's no way you can jump to the, even though they may appear to be parallel, we have to have some kind of proof, and there's not enough on 5. 6, same markings. So this mark is a congruence mark. Wherever it shows up, they're the exact same. So if this is like we just did before, that's 70. Now it's linked to these left 4, so that would also be 70. Then you can fill in the rest. 110, 70, 110, 110, 110, 70. If you can fill in all 8 and the left 4 are the same as the right 4, then yes. But the reason these markings are in corresponding locations. So my answer is yes, because corresponding angles are congruent in parallel lines. Only in parallel lines. Okay, look at the diagram. Use the given information to figure out which lines are parallel. So angle 13 is congruent to angle 11. Angle 13 and angle 11. Okay, those angles, so look what we were talking about. 13 is in this left 4, and 11 is in this right 4. So you're linking line M to line L. So this is going to be M is parallel to L. And 13 and 11 would be alternate exterior angles. Number 11, 4 and 8. Okay, 4 is right here, 8. You're still linking line M and L. Those 4 are linked to these 4. So you're hooking line M and line L. 4 and 8 though are corresponding. So this would also be M and L. 12. Whoops. 16 and 2, so the circle 16 and 2. 16 is there, 2 is there. Now I linked these 4 with these 4, so that means I'm hooking this line to this line. 16 and 2 would be alternate exterior angles, but we are using line N and line Q. Last one, 7 and 9. 7 is here, 9 is here. I'm linking these 4 angles to these 4 angles, so I must be linking this line to this line. So the same as before, N and Q. Alright, so find all the missing angles. Let's just maybe make a list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let's start with this. If that's 42, this will also be 42. So we get 2 is 42. And you can find 1 because those are a linear pair, so that's got to add to give you 180, so they're supplementary. 180 minus, take away 42 is going to be 138. So 1 is 138, and if 1 is 138, so is 3, because they are vertical angles. Okay, so I got the top 4 kind of figured out. 138. The next one that's going to be slick is that guy. 10 has got to be 90, because those are a linear pair. This angle and this angle are corresponding, so 8 must also be 90. And then I know this. I know 5 is 90, because that's a vertical pair. And I know these have to add and give you 90, 7 and 6, and these have to add and give you 90. So we just got to figure out what 7 is, what 6 is. We're going to have to use this. So let me take the picture apart. I'm going to take this vertical line out of it. So the top 4, here's what I got. 138, and that's 42, and then we got 42 and 138. So if I take that vertical line out, this is going to be 138, this is going to be 42, this is going to be 42, and this is going to be 138. Okay, now here's what I'm going to see if I can find. 42, this angle and this angle are the exact same thing. So this angle is angle number 2, but this angle right here is angle number 7. So 7 is going to be 42 degrees because it's corresponding to 2. It's in the same spot. So sometimes for me it helps to just draw a separate picture and take out some of that, some extra lines. If 7 is 42, then I know this one's going to be 42, which is angle number 4. So 4 is 42 degrees. And then I can get 6, because I know 6 plus 7 has to be 90. So if I do 90 subtract 42, that's going to give me 48. So these guys, 7, 6 has got to be 48 degrees, and 9 is a vertical pair, so it must also be 48 degrees. Because look at 2. Okay, number 2, let's do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Number, okay, we can start off right here. 53. 53 is going to also be 2. So 2 is 53 degrees. And then I know they're supplementary. These guys are a linear pair. So if I do 180 subtract 53, that's going to give me 127. So angle number 1 has got to be 127 degrees. Angle number 3 has got to be 127 degrees because they are a vertical pair. So I got those knocked out. And what else can we do? Alright, so we are going to, so this one, if I take out that vertical line, so I just found these. I just found 53 and 127, 127 and 53. So I know these guys over here got to be the same. 53 and 127, 127 and 53. So I can get angle number 5, because there's my 53 right there. This 53 is angle number 5. So 5 is going to be 53 degrees. Now what else can I get? I think I can get angle. I know this guy right here is 127. 127 is number 1. But on this 127 is these two guys added together. So I'm going to take my 127 and I'm going to subtract the 90 degrees, and I'm going to get 37. So this little sliver, angle number 4, must be 37 degrees, because 37 added to my 90 is 127, and I know that whole thing has to be 127. So angle number 4 is going to equal 37 degrees. Okay, look at angle 6. Angle 6 is a vertical angle with this. So if that's 90, 6 must be 90. Okay, now I'm going to, let me erase this stuff because it's getting a little too sloppy. So now I'm going to draw another picture, but I'm going to take out, so I'm going to still draw these two lines, but I'm going to draw the vertical line in there. So let's see what we got here. I'm going to take out that horizontal line. Let's see if I can get these bottom ones, 7, 8, 9, and 10. So if we put, I know this guy is 37 degrees, and that's my number 4. So that guy is going to be 37. This guy is going to be 37, and this guy is going to be 37. So I just found 7 and 9. So 7 and 9 have got to be 37 degrees. Okay, the other ones, 9 and 10. I think I wrote that in the wrong spot. Okay, so 9 is going to be 37 degrees. I got to find 8 and 10. I got to find this one and this one. And they're going to be supplementary to 37. So if I take my total of 180 degrees on a straight line, subtract 37, I am going to get 143. So 8's got to be 143. 10 has to be 143. Find the roots. So they just want you, this is a big hint, they're giving you a quadratic equation. We may have to use the quadratic formula. So move number 1, you got to get everything on the same side. And if you look at this, your right hand side has got to be played with a little bit. You've got to first move, distribute the 2 to both those terms. So let's just copy and paste the left. 3x squared minus 7x minus 30. The right is going to be 2x squared minus 12x, and then copy and paste the minus 6. Okay, I'm going to move everything to the left to keep my x squared positive. So I'm going to move that over, move that over, I'm going to move that over. So I'm going to minus 2x squared minus 2x squared. You're going to have x squared minus 7x minus 30 On the right, that zeroes out, so you got a minus 12x minus 6 plus 12x to both sides. Now you got x squared minus 5x minus 30 equals, that zeroes out, and you got a minus 6. And now if you just add 6 to both sides, plus 6. Okay, we're going to go x squared minus 5x minus 24. So it's a little bit of work. I turned that mess into x squared minus 5x minus 24. And you can continue your quadratic formula, find a, find b, find c. A is going to be 1, b is negative 5, c is negative 24. But hopefully you remember back from your quarter 2 days, this guy might actually be easier than quadratic formula, because anytime this is 1, let's see if we can factor it. Can you rewrite this as a multiplication problem? And if you can, then your answer is going to be quite a bit easier than quadratic formula. But you will get the exact same answer if you choose to go with quadratic formula, so whatever way you like. But what I'm looking for, does there exist two integers that multiply and give you a negative 24 and add and give you a negative 5? So remember the template. What two numbers times give you negative 24, add and give you negative 5? And your answer should be a negative 8 times a positive 3. Negative 8 times positive 3 is negative 24, but if you add them, it is a negative 5. So I can rewrite this. I can factor this. It's going to be x minus 8 and x plus 3. So this way is going to be pretty fast, because my answer is going to be x has to be 8 or a minus 3. So anytime your answers are from the integers, factoring is definitely the way to go. But if your answers are going to be rationals, irrationals, or imaginaries, then quadratic formula is your slickest route. Okay, show them on a number line. So this next part, show those two on a number line. Integers are pretty slick to show on a number line. So if you've got a number line, let's say 0's right there, 8, there's my 8, circle it in, there's my negative 3, there we go. There's where those two roots would end up on a number line. Okay, back to some geometry stuff. So find x and find y. Maybe I'd start with x right here, because those two are a linear pair, so they must add and give you 180. So if I take the total 180 and subtract what's being used, subtract 83, you should get 97. So x has got to be 97. Okay, these two marks mean they're parallel. So if this is 83, this is 83, this is 97, this is 97. And the same for the bottom. This is going to be 83, 97, that's 83, that's 97. I can find out all 8 angles. But now I'm going to use this data right here. If I know that 83 is equal to y minus 13, I know that y has to equal 83 plus 13. So y is equal to 96. Y has got to be 96. X has to be 97. Number 4, kind of the same idea. You're going to start right here. Start with 98. Okay, if they're parallel, which they are, that's 98. That's 98. That's 98. That's 98. Those 4 are 98. The other 4 are going to be 180. Take away 98. So they are going to be 82. So this is going to be 82, this is going to be 82, this is going to be 82, that is 82. So now to find y, let's find y first. If you know that 82 is equal to 2 times y, y has got to be equal to 82 cut in half. So y has to be equal to 41. So there we go, y equals 41. And now let's see if we can find x. So x add 9. Some number added to 9 has got to end up at 82. So let's minus 9 minus 9. X has to be, what is that going to be, 73? I think it's 73. Okay. So those two aren't too bad. Alright, back to a quadratic. So solve the equation, find the roots, solve for x, it's all the same thing. Let's get everything on the same side. I'm going to keep my k squared positive. So I'm going to move everything over here. I'm going to move everything to the left. So I'm going to minus 9k squared, minus 9k squared. 12 take away 9 is going to be, so I got 3k squared and a 12k. And on the right I got a 12k and a 4. Those cancel out. So I'm going to minus 12k, minus 12k, and on the left and the right those both zero out. So I got 3k squared, and on the right I got a 4. So now I'm going to minus 4, minus 4, 3k squared minus 4 is 0. Okay, now because this starts with 3, I'm just going to go ahead and start using quadratic formula. So quadratic formula, as soon as you get everything on the same side, which we do, determine the value of A, determine the value of B, determine the value of C. A is 3. So it comes from this, ax squared plus bx plus c. A is the number in front of x squared, that's 3. B is the number in front of x, and I don't have one, so that's going to be a 0. C is the constant. C is the number all by itself. So you're going to use this, then you're going to use x equals negative b plus or minus square root b squared minus 4ac all over 2a. So I start singing the song and plugging in x equals negative 0 plus or minus the square root of 0 squared k. Put these in parentheses because this is the number one mistake. If you square this, 0's not going to affect this, but if that were a negative number and you didn't put it in parentheses, the calculator would give you a wrong answer, and then from there on out you'd be jacked up. So to be safe, always put this b squared in parentheses. Minus 4 times a is 3 times c is a negative 4 all over 2a. 2 times 3. Alright. Okay, now it's calculator. So now my next move is going to be, I'm going to ignore this plus or minus 0 or minus 0. I'm going to go plus or minus. Okay, that whole square root should clean up. If you just type that line in exactly as it is on your calculator, you'll get it right. So 0 squared minus 4 times 3 times a negative 4. You should get 48 under there. And then 6. Okay, now see if this is a whole number. If this is a perfect square, you're in business. If it's not, that's going to be a little more work. So square root of 48 comes out to be a decimal. So it's not a perfect square. So from this point, you have got to see if you can pull anything out of 48. So let's factor down to its prime factors. 6 times 8, 2 times 3, 2 times 2 times 2. Okay, my next move. I am going to trade out a 48. I'm going to go plus or minus the square root of 2 to the 4th times 3 to the 1 all over 6. Okay, now since it's a square root, I'm going to pull out some 2's. You have to pull them out 2 at a time. So I can pull out, it's going to be plus or minus 2 squared. On the inside there's still a 3. On the bottom you got a 6. So let me come up here. we have got plus or minus 4 times the square root of 3 over 6. Simplify this right here. 4 over 6, that is going to reduce. You're going to have plus or minus 2/3. Okay, this is your final answer. Plus or minus 2 times square root of 3 over 3. Now, the cool part, if you show this on a number line, if you have to show this on a number line, 0 is right there. Let's do the plus one. 2 times the square root of 3 over 3, just type that in your calculator. 2 times the square root of 3, and just, it's going to be a decimal. Then divide that by 3, and you should get 1.15, blah blah blah. So 1.15, here's 1, here's 2. This is somewhere right in between 1 and 2. And the negative is going to be a negative 1.15, so it's going to be right in here. So your answers on a number line are going to be the positive roots right there, the negative root is right there.